All right, mathletes, it's 6.4, sum and difference formula, day 2. So what we're going to end up doing is really trying to get to this point where we can find the cosine of alpha minus beta. If we don't know alpha and beta, but at least we are given some information. We are going to be given a sine of alpha and a cosine of beta. So working from that, we should understand from our formulas, as long as we know sine of alpha, we can find cosine of alpha. If we know cosine of beta, we can find cosine of alpha and use those 4 trig functions to execute this. So as a review, if we're given one trig function, and I know which quadrant it is, pi over 2 pi, I know that's the second angle. Okay. My sine is opposite over our hypotenuse. Solving out this, knowing that it's a second quadrant angle, x has to be negative, so this is going to be negative square root of 3. So as I find my cosine, this is my alpha angle. My cosine of alpha is equal to negative square root of 3 over 2. It's on our unit circle, but we can do that with any one. Notice we can also plug it in to our Pythagorean identity and work it out correctly, and we get the same solution. Alright, so what happens if it's not on the unit circle and we don't just recognize that? So if I know that my cosine is between pi over 2 and pi, I know it's going to be a second quadrant angle. I know that my adjacent side is negative 1, hypotenuse is 3. Solve my Pythagorean identity out and get my opposite side. So then I can go ahead and find my sine of beta to be 2 square root of 2 over 3. So now that I have all 4 of my trig functions, I have both sines for alpha and beta, cosines for beta and alpha. I can go ahead and use my identity here for cosine of alpha minus beta and just substitute and simplify. So cosine of alpha is the square root of 3 over 2. Cosine of beta is a negative 1 over 3. Sine of alpha is 1/2. And sine of beta is 2 square roots of 3 over 3. From here, just simplify this out. So I get positive square root of 3 over 6 plus 2 square roots of 2 over 6. And square root of 2, square root of 3 aren't the same, so I just leave the numerator as it is. And I can write it over as Alright, so the second type of question we're going to be asked is dealing with tangent functions. Just like our sine and cosine, we can use sum and differences of tangents. Just recognize for an addition of alpha plus beta, we have addition in the numerator, negative in the denominator. For a minus, we have a minus in the numerator and addition in the denominator. We're going to get back to principal angles here. So if we're given that the inverse sine is 12 over 13, we got to remember that sine inverse, you're going to get your principal angle. This is positive. So because it's positive, we know it's going to be a quadrant 2 angle. So I can draw my picture, 13, 12, and that's going to force my adjacent side to be 5 by solving the Pythagorean theorem out. 5, 12, 13 is a Pythagorean triple, so I know that by heart. Next piece that I have is my inverse cosine is negative. Well, inverse cosine is negative. The principal angle is a quadrant 2 angle. As I draw my triangle, I'm going to draw it in quadrant 2. I'm going to hold the radius always to be positive, so that's fine. Negative 3 here. And this is going to be 4, forced again by a Pythagorean triple, 3, 4, 5. So now that I have these triangles drawn, I got to remember that this triangle is relating to my angle alpha, and this triangle down here is relating to my angle theta. So I can find my other trig functions just like we did in chapter 5. So going off of those, again, I have my alpha and my beta here. So I can find my tangent functions of both alpha and beta, and I can use my sum and difference formula for these. So tangent of alpha minus beta is tangent of alpha is 12 fifths minus tangent of beta, negative 4 thirds, all over 1 plus tangent of alpha is 12 over 15 times tangent of beta, negative 3. So then simplify these out. I need a common denominator in my numerator. So this is going to be 3 over 3, 5 over 5 multiplied by 1 so that I can get a common denominator. 36 over 15. Negative, negative makes that positive, plus 20 over 15, all over 1 plus negative 48 over 15. Reducing this, I'm going to get 56 over 15, all over, well, 1, this is the same thing as 15 over 15 on the denominator, and I get negative 33 over 15. Dividing by something is the same thing as multiplying by its reciprocal. So I get negative 56 over 33. I encourage you guys to check your answers in your calculator. Notice I can bring up my calculator and I can say tangent of inverse sine of 12 over 13, close that out, minus my principal angle, cosine of negative 3 over 5, close that, and I get that decimal expansion, and I can verify that my negative 56 over 33 is the same decimal expansion showing that they're equivalent. All right, that's our notes for tonight. Make sure you highlight your questions and bring them tomorrow.